von Berlin, Red Raider Robotics.
Welcome to Chatting Around the Campfire. This week's episode is presented by Red Raider Robotics. I'm Erica.
I'm Flynn, and today we're joined by Luke and Chris. Luke is a project manager on Build Team, and Chris is also a member of Build Team. And today we'll be discussing Build Team as a whole, as well as diving into their design process and build process. So let's get chatting.
So, first question, pretty easy. How did you guys get into robotics?
I got into robotics because I had some friends on the team and they encouraged me to join, and then I did.
I got into robotics because, one of my elementary school teachers, she began a Lego League team, and I began with first Lego League. I really enjoyed that, so then I moved into robotics.
Nice. And how many years have you been on the team?
This is my third year on the team.
This is my fourth year on the team.
What do you think, in your experience, has been the best thing about robotics? Like your favorite moment or your favorite thing?
I just enjoyed spending time with the people here. I have friends on the team. It's a good time there, and then being able to practice skills for future career and stuff.
I enjoy working with the machining and being able to learn all the information and all the knowledge that the mentors have to share with us, and I really enjoy spending time with the people on the team.
Mm-hmm.
So Chris, in your expert opinion, what are the skills needed for a successful build team?
For a successful build team, you definitely need communication. Communication is really good because if people are not communicating, then you may be building more parts than you need or not enough parts that you need. It really depends on how much communication the team really has.
And how much communication do you have with design team? Because they're constantly making updates and they want to make sure what they make gets onto the robot.
Well, I feel like we have pretty good communication. I feel like at times we get a little iffy with the communication, but we try to stay on top of everything.
I think that's been a big stress on the team over the past couple of years, just nailing down that communication between all the teams.
And that's also why we added project managers.
Yes.
So how many members should a build team consist of to be successful?
Well, it can really vary from any day to day depending upon how busy we are and how much stuff we have to do. But I'd say usually probably 8 to 10 people is usually a good amount, because you can have people running to go grab stuff, you can have people working on the robot, you can have people working on machines, and then maybe talking with design team and kind of helping to oversee and give hands where needed.
Is there ever when you have too many people, how do you keep everyone engaged? Try to keep everyone engaged as a project manager.
So if there's too many people for one topic or for one need or one job that needs to be done, usually we'll have them go. Sometimes if there's nothing to do, we'll just have them work on cleaning and organizing, but we have the toolboxes that we take to competition, organizing those, labeling them, working on a sheet set organization, and then also kind of talking with design team. Sometimes going over designs can be helpful, giving an extra hand wherever it's needed.
Mm-hmm. You talked about design team a little bit. How much say do you have in what ultimately gets chosen as the design? Build-wise,
so usually we don't do a lot of nitty-gritty picking at the design. We can sometimes we'll consult with the design team and kind of talk about general concepts, ideas that might or might not work. Maybe it's a part looks good on paper but isn't really practical for actual use, and then we kind of talk that out, and that helps. And then also as a project manager, I get to kind of go back and forth, so I get a little bit more of both worlds as opposed to someone who's purely on manufacturing team.
Yeah, and as a leader in your group, how do you delegate tasks efficiently, and how do you manage your time?
So usually I kind of go wherever I feel that there's the most need for assistance, or wherever if on one day, I don't have many designers show up and I have a lot of manufacturers and they all know what they're doing, I feel comfortable letting them do whatever and I'll help my designers, and then vice versa. If they all have a task to do, I'm not going to interfere and I can go help build something.
This is a very different question. There's zero lead in. But what are the most common challenges you would like face in a normal meeting?
So common challenges, sometimes we don't have the parts that we need or don't have them in the right places. Sometimes we just don't have enough machines to do everything that we want to do. Sometimes we don't have the right people. Like when Andrew got sick, we couldn't run our CNC machines, and then that set us back a little bit because we didn't have anyone who knew how to run that, and then we couldn't make certain parts that need that precision of the CNC. Sometimes also just being disorganized can kind of hurt, because if people are just picking things up, setting them down without following a specific system, then nobody is going to know where everything is at any given time, and it can make things a lot longer to pick them out.
Obviously, we have a lot of mentors around our team. I know our team has 2 or 3. How do your mentors help you with the process?
Okay, so they are 2 main mentors for manufacturing, both work in manufacturing, of course, and so they have a lot of knowledge on the specific tools and how to run machines, and they have a lot more in depth to their knowledge, so they're able to assist and guide whenever someone doesn't know how to do something or needs assistance or advice, so that we can make sure that everything is done correctly.
You talked about like they know their tasks and they can be able to teach someone. Like Andrew knows how to use the CNC machine really well. Like, is there a certain like tool or process that you both have like a really good handle on, and like if anyone on the team were to do it, it would be you?
Tasks, I can do a lot of the more like basic stuff. Like I can do basic milling, and then a lot of like the hand tools and power tools and stuff that work with the robot. I feel like I have that down pretty well, and I can't speak for Chris.
I feel like I know how to use a majority of the machines that we have in workshop, but with some of them I feel like I personally have found myself asking mentors for assistance. Last year when I was doing the milling, I was able to do it by myself and I remembered how to do everything, but when I came back this year, it had been a while, so I didn't really remember how I was all supposed to do everything. How to zero a tool, I kind of forgot to do that.
Yeah, that too.
Yeah, so I have the mentors help me when I find myself in a difficult situation.
And how do you handle that tradition? You talked about summer. We obviously aren't in the shop every day perfecting our abilities. How do you handle coming back into it and teaching the freshmen as well as freshening up your own skills?
So usually I like to go through just a quick kind of refresher with someone else at the beginning, because it comes back to me pretty quickly, but there's just some small details and parts of the process that you want to make sure you have completely, down pat. So you'll usually go over it with someone and just do a little bit of practice before I go on to teach someone else, rather than just trying to teach coming back from a break, because this is really the only place where I have practice or use in anything like this. As far as teaching other people, a lot of it is stuff that I have learned before, so once I remember it, it kind of just comes back to me, and then I can pass it to other people.
And you guys have a lot of the preseason to relearn the skills that you already have. And so when you're transitioning into build season, what is the first thing you start with when you see the robot reveal, or game reveal?
So the game reveal, usually I think at the beginning of the game reveal, it's a lot focused on designs and design concepts. And we usually start doing a lot of prototyping, just really quick, using drills as your motor, and laser cutting and 3D printed parts, a lot of that. So that's not a lot of our area, but we just kind of assemble it, put it together, and just start thinking of concepts before we move into getting actual designs done.
Not to get too off task, what did both of you think about the game this year?
The game, it was interesting. It was very similar to the FTC one, which I did a little bit with earlier this year. It seemed simple to me, but I think it has potential to be fun.
I'm waiting for like a match where every single cone and cube gets stored.
Oh, that would be something.
Chris, what's your take on the game?
I think the game is very interesting. I think it's a cool concept because every other game that I've been a part of has included like spheres of sorts,
Balls.
Yeah.
Like all the games that I remember include balls. So it's interesting to move on from that and now have to work with cubes and cones. Yeah. I personally didn't get to watch kickoff, but I watched
That's good.
the kickoff video by myself. It was pretty cool.
So how does build team like prepare for a competition? Take me through the week before.
Alright, so the week before, well, usually it involves a lot of last minute assemblies, last minute parts, making sure everything's in order. But as far as making sure, separate from actually making sure the robot works and is together in one piece, we have to make sure that our pits are ready and a lot of the stuff for our pits. So we have the two toolboxes that we bring with all of our tools and extra parts and basically anything that we might need in case the robot breaks. And we usually like to go through, inventory them, put them all together, organize them, put everything all in order, check in on the tools, make sure that they're in working condition, and make sure that we have all the parts that we'll need. Other than also kind of making sure that people who want to do pit stuff are doing pit stuff and then getting them the practice to do that, a lot of hands-on stuff with the robot.
As we continue on with our questions, what are the steps involving building the robot? Like, what's the first thing you do?
Okay, so the first thing is design makes sheet sets for us. And they tell us which parts that we need to build. And then we go over, we take them, we build them. Usually we have to build them a lot of times because they keep making changes and there's a lot of revisions. So we go and we take them over, and then once we have all the parts made, we have them all up to date, then we get assembly drawings, and those basically tell us how to take all the parts that we've made and put them all together to make a functional robot. And then we put everything together in the way that it's supposed to be together, and then we have a robot, and then we hand it off to the programmers. And usually it's not all one big smooth transition. Usually involves kind of going back and forth, putting things on, taking them off. It's kind of a big mess, but it all comes out to one robot.
Typically, we start with the chassis first.
Yes, that's
typically the first thing we build, so that programming could get.
That's the base,
the base, all big program.
Usually it's kind of built like from the bottom up.
Yeah.
And then we like prioritize past the chassis, we prioritize like the parts that are right next to there, and then
they're always prototyping what we're gonna do for the top half, but typically the chassis is the main focus in the beginning.
Yeah, so can you talk me through like how you went about building the Swerve chassis that we have through the summer? Like, was it a super big like change or?
So as far as build wise, we obviously bought the Swerve modules from Swerve Drive Specialties. So we went, and beginning of the school year, I had some classes over here, and I know a few other people did. So we kind of took that took that time to go and assemble them. They're just based off of some instructions, put them all together. And then as far as actually putting them together into a chassis, we had Max go, and he came up with just a quick design of some bars that can all go together to support like the chassis and its electronics. And we just drilled holes out on those bars, put the assembled modules all together, and then there's our chassis.
So in a way, a robot is just a big Lego set.
Sort of. I guess you make your own Lego pieces.
Yeah.
I guess you can see it like that, yeah.
You also talked about
for a reason.
Yeah, like the prototyping and having to redo sheet sets multiple times.
Yes.
We have 2 robots this year. Can you talk about that a little bit?
Okay, so the idea behind having 2 robots is that one is you can use for prototyping, and if you have new parts that you want to do or want to try out, new parts that you want to throw on, you can throw them on the one robot and then put finished parts on the other robot. And the other idea behind it was for a programming perspective, was because in previous years, from what I've heard, was that what would happen oftentimes is that designing and building would run late into the season, which would leave the programmers with not that much to do for the first majority of the season, and then have to crunch all their work back into like a week or two at the end of the season to get everyone ready for competition. So to combat that, we had 2 robots so we can work on assembling, prototyping, building on the one robot, and then that progress is still going, but you can still have someone working on programming, testing code, making autonomous, that sort of thing with the other one, and they're not running into each other, and we're not having to borrow the robot back and forth.
Yeah.
And on top of that, in competition, if we have 2 competitions right back to back, let's say we have to go onto the field, we come back, our robots has some issues.
Yeah. Or has some issues too.
We have another, competition in like 15 minutes. We can't cram all that together, do it all, jerry rig everything together, essentially. So instead of doing that, we can do more in-depth analysis on what's wrong with the robot, get it all fixed while we have the second robot out on the competition floor.
So we're allowed to use both robots?
No?
I don't think you're allowed to, because you can't enter 2 robots into the one competition per team.
I thought Mr. Severns was saying that though.
No, I believe the point that he was trying to make was like when we went to our scrimmage or whatever, if the robot got damaged at the scrimmage, we have our competition coming up, we don't have to use the same robot for that one and the competition.
Well,
because it's one robot.
I misjudged the situation then.
Yes.
But like we do have a competition and then a week later another competition.
Yes.
So say if our robot was to explode,
we could enter the other one into the following
the next
competition.
According to our safety,
I believe
he
that's.
said that one of the robots caught fire. So if that happens, not one of
it's
our robots.
possible.
Okay.
In the past, a robot has essentially caught fire, from what he told me. So if that happens to us, we have another one.
that's
Awesome.
So, as a business team person, I have no clue what is in the robot or how you make it. So, well, I actually made the bumpers, so I do know how the bumpers are made. But why don't you walk me through like what materials you use and how they can be fire safe, I suppose.
Okay, so a lot of the material is aluminum. That's like what the vast majority of the robot is. This year we opted to go with C-channel aluminum. So basically it's like a 1x2 inch bar, except one of the long edges has been cut off, so it looks like a C. And then that idea is that it cuts a little bit of weight off, but it still keeps a lot of the strength. And then we have that together. A lot of our bars and stuff are still that aluminum. Certain specific like spacers and specific parts we use a lot of 3D printing and like plastics for. And as far as that, just a lot of bolts and stuff like that. I don't know what else there is a lot of. Yes, we do use polycarbonate for a lot of our sheets and plates and stuff because it's kind of flexible and it'll work.
So that's typically what we use to put the electrical systems on top of.
Yes.
Is there ever like a time where, I guess, you do have good communication with the design team, but do you ever like envision a time, or has there ever been a time where design has a great idea, but like the materials that we have aren't necessarily strong enough to make it function?
I don't know about that specifically, because usually if they have an idea at the beginning of the season, we can order materials or specific parts that we end up needing. Now, if we get to the end of the season and someone has an idea to fix something or alter something and we don't have the parts, then sometimes we do have to kind of get rid of them or alter them a little bit. but for the most part, it's never really been a big issue. So we also do have a lot of extra stuff as well for most things that you would need other than ultra specific parts.
And with materials, there's also like a weight and a height limit. Have you ever like been like building something and you're like, oh no, like it definitely exceeds the weight limit, or?
Well, I know last year we didn't actually end up building it, but we were designing our climber system at the end of in between competitions, because we had the one like that wood climber and that didn't work very well, so we wanted to go to a pneumatic climber, and we had people designing it and realized that we were going to be like over 30 pounds overweight just based off of what the fusion told us. And we were looking at that and we just had to scrap it because there was no way that we'd be able to just cut 30 plus pounds and still have it function the same. So in that case, yes. This year it's really not an issue. We're like, I think over 20-30 pounds underweight, so we have room to play with, which is good. That's really the only example I can think of.
And you talked about changing our climber from the first competition to our second competition. That's like kind of one way we've tested our robot. We also had Sussex this past weekend. Besides like a scrimmage or competition, how do we test our robot to see if it works?
So we do build like mock game pieces, mock parts for the game, and put them over in the ATC, the machine shop. So we have our own like our ramp, we have our own poles and places to put cones and cubes. So we can still go practice lining up, getting on the ramp and all that. It's just sometimes hard to visualize because we don't have like a full field with other robots working how that'll all play out. But we can test the mechanisms to make sure that they'll do what they're supposed to do. It's just that this strategy is harder to find out.
We build about half of the field, I want to say.
Yeah, it depends upon what each game is.
Quarter, part of the field, and then that is also where programming comes, and then they test out autonomous, and so it helps.
Well, that's all I have. Do you have anything else?
I don't have anything.
You guys?
I don't think
Anything else? All right. Well, thanks for joining us on this episode, and we'll see you next time around the campfire.